Hey guys, so we're working on our game engine today. It's a milestone one. We have a couple of features that we're gonna show today. Uh, One of the feature is our model viewer. It is gonna have a model, and we're gonna create it in a runtime format so that it's easier for the engine to load it at the same time. Um, we are also gonna be creating different copies of the game objects on the window during its running. Also, we are adding bounding sphere. That's kind of like which can be used for collision and everything. The bounding sphere is like just a sphere that's gonna be calculated during our FBX conversion. So we're gonna start with the FBX code first. This is our model file header. This is actually the old one. Let me pull it up, the newer one. Okay, here you go. So we have added a bounding spheres on this code. We are using our file library to create the files. Return sphere is the one that is going to calculate our sphere calculations for center and radius. And we are creating packages which has the header, which has its name, number of vertices, the vertex buffer, the number of try list, the try list buffer, texture name, we are storing the texture name, and the sphere data. So once we just simply load this, we get an exported.exe file that we are putting into our this file has all the images, the textures, and the FBX models and everything. Let's just clean it up a bit so that we can reuse it, and let's remove this package as well. So this is the files that we are using. That's the standalone programs. FBX converts the file from XPX to Azul format. Then we are using Vodka for program that we used in our PA1, and we are creating the binary linked objects, and then we are creating a whole single package. We are making package chunks of all the textures and everything as well. So let's just run this code first. uh, let's while it's running, let's just go to our viewer, model viewer. This is our game engine. The game engine, we are setting up two cameras. This camera is just we're gonna use this as a first. Like normally we are not actually using this camera yet. It's just there. You can do the functions if you want, but it's not actually being used much. uh, what we are doing is like we are changing the camera position to a specific object, and we can circle around that object. It is running through all the game objects, so if you press next, it will move to the next object that's in the hierarchy, and it will move to the next. If you reach the last object, it will rewind back to the first object. This is our shaders. We are adding all the textures. So here you can see we are not actually adding any kind of like TGA format or something, because we are reading it out from the single package file. Uh, you can see we have all the the binary linked objects created, the Azul files and everything, and this is our package that has everything. That's a 14 megabyte package. Um, as you can see, the FBX is converting the to Azul file. So if you can see, this FBX is like 1 megabyte, and once it's converted, we are using just 151 kilobyte of data that is required, that is actually required for creating the objects. So you can see here we are just like sending out the names, and we are linking it to a specific texture name. And you can see that space texture, that's polar bear. You can use a war bear as well if you want. It can be like there's two textures for the same object. This is our code for turning off and on the bounding sphere. We're just like turning it on and turning it off for all the objects. It's a keypad plus sign and keypad subtract sign that we are using to turn it on and off. That's if you want to change your camera. We're not actually using it too much though. And then this is for the next camera actually. Whenever you go through this, it will move to the next camera and next object and in the hierarchy. And this is our code to create new objects from Game Object Manager. Alright, let me show you the Game Object Manager here. So we are just simply creating the new object. I'm just like creating random, so I've just created this seed, passing the seed in and doing the code for that. And in case if it's a 0, 1, 2, or 3, it depends. We're passing space and the texture related to that. Because we have all the textures already been linked in there, we're just creating a new space model and sending in the texture that we want to use with the model. And once it's done, well, it's not really a texture, it is just the name of the model, and it is getting extracted from the runtime binary file that we have created. Then we create a light object and just creating an instant, setting a position. We are using the last position of the last created game object. It is not going to use for any other thing, and just putting in a new position of the game object so that it can use it to create it next to the last object. For game object, we have added like extra sphere object in there. That's a graphics object. We needed a graphics object in there because we are creating a sphere around that. We are getting the data from the actual graphics object of the game object itself, and we're getting the center and radius, and we are doing our calculations. We are doing the same thing for the sphere object for what we are doing for the game object, because we want to keep the size. If it changes, it's gonna change for the sphere as well. The process is similar. If the sphere is not null and the sphere status is not false, then it's gonna be done, processed. You can see when we are drawing and doing the same process for that. We're creating the bounding sphere here. That's the first thing that we are getting calling at the time of constructor, and we are doing our calculation here, setting it up in such a way that it's the perfect position according to the size and scale of the game object itself. This is just turning on and off the bounding spheres. If it's false, it will not show up the bounding sphere. If it's on, it's gonna show up the bounding sphere. Alright, this most of the code and the most important code actually. This camera, we have a plane and everything. We did have created a new kind of code that we're gonna show you on a different project that's for bounding spheres, but it is detecting the way it is moving around and everything. So let's start by just running this code first. Alright, so that's our code. If you turn it around, we'll see the light on the beer. Once you press G, it will create a new game object, and If you press plus, you'll see all the bounding sphere around the objects. If you press G again, you'll see new game object and N as well. And if you press N, you'll move to the next object. It actually using the actual position of the camera that was initially, and as well. So once you turn it on and off, you can see the whole game object and the texture that it has around it. You can see all the things in here. We still have to figure out the actual rotations of the objects because some way it's kind of weird, but we can set it up. It's kind of quick fix that we need. So these are the four different objects that we have used here. Let me move to this. That's our space frigid that we're using. Then that's our beer, that's our Astro Boy, and that's our buggy. That's the four different game objects. If you like keep doing it, you can like keep populating it on the screen. You can see them getting populated. It is doing because we are doing a random, so it's just creating randomly for that. Alright, so we do have another project that is kind of interesting as well. That is a bounding sphere project. So here, if you can just run this code here, you can see the two space bridges going out. Right now it's a green color. You can move around and see it. And once it reaches the specific height, or it reaches the specific frustum plane, it is actually turning into a different color. This is going to be used for if we want to draw the game object or not, because once it's outside of the frustum area of camera, we can just like let it not actually draw on the screen here. This is like a changing value for any game object, so even if it's a X, Y, Z or any kind of direction, it can be done by the code we are used here. So that was basically most of the stuff that we have done for this milestone. Let's hang on for the future as well, because we are coming out with animation as well. Thank you and have a great day.